Today we're going to talk about the derivatives and integrals of bases for bases other than e. We talked about the properties earlier, and now we're going to talk about the integral and the derivative of bases other than e. So we're going to let a equal a positive real number other than 1, because remember 1 to any power is just going to be 1. All right, let u be a differentiable function of x, which means we can take the derivative with respect to x. All right, so here would be an example. So the derivative of a to the x is just going to be a natural log of a, so the natural log of your base times a to the x. All right, and again, same things. It's just going to be the natural log of the base times what we originally started with, and then if we have a function up there, so maybe like 2 to the 2x up there, we'd have to multiply by its du. We're always going to let the exponent equal u. Okay? That's been a fairly consistent thing all the way through these sections. All right, and then if we have a logarithm, all right, our logarithm is just going to be 1 all over the natural log of the base, so our base is a, so if it's like a base of 2, log 2, so it'd be natural log of 2 times what's in the inside. All right, same thing if we have maybe a function, maybe we have the log of 2 times x plus 1 or whatever. All right, we'd let this inside equal u, and we'd take the derivative. We'd have 1 all over the natural log of 2. All right, times our u, so it'd be times x plus 1. All right, and then also times du dx, which would be the derivative of the inside, which actually in this case is just 1. All right, so there's a few examples of our derivatives for something other than, whoa, a little too far there. Derivatives other than with other bases. So example 1 here, find the derivative of the following. All right, let's get it up here so we can see our properties as well. Okay, so a to the x, all right, the derivative of a to the x is the natural log of a times a to the x. So we have we're gonna have the natural log of our base. So the derivative of this, so y prime is gonna be the natural log of our base times 2x. That's it. All right. About b, remember, as long as we had a function up here, we're going to make this equal u, right? So let u equal 3x, and we could have done it up here. We could have let u equal x, all right? But the derivative of x is just 1, so it didn't really matter. All right, we could have made that u, and then it would be times 1, right? Then du would equal 3, right? 3 dx. So dx equals du over 3. Anyway, du dx would equal then, sorry, this is our formula, du dx would equal 3. Okay, so our formula over here says the natural log of the base, so y prime is going to equal the natural log of the base, so natural log of 2 times our original problem, so 2 to the 3x, times du dx, which is actually just 3. And we can simplify this a little more, I guess. We can say this is going to be 3 times the natural log of 2 times 2 to the 3x. So that's b there. All right, here's a logarithm 1. All right, remember we said if we have something in the middle, we're just going to let it equal u, or inside we're going to let it equal u. So let cosine equal u. All right, let's get rid of this other stuff. Here you go. Let's let cosine equal u. U equal cosine of x. So du equals negative sine x dx. So du dx equals negative sine x. All right. Well, in our equation over here, it says 1 all over the natural log of the base. So we're going to have 1 all over the natural log of 10 times our inside, which is times cosine, so times u. All right, and then all of that times du dx, which is a negative sine over, or sine of x over 1. We could say like it's a fraction, so we could really write it as negative sine all over x all over natural log of 10 cosine of x. If you remember back for our trig days, we know that this equals tangent, right? So we could say actually, what's what? Negative tangent of x all over the natural log of 10. So there we go. That's just a little simplifying at the end is all it was, but there's a few examples of taking the derivative with bases other than e. Integration of an exponential function to another base. So the integral of a to the x dx is 1 all over the natural log of the base times our original function. All right, so if I wanted to evaluate the integral of 2 to the x, all right, the integral of 2 to x is just going to equal 1 all over the natural log of the base times what we started out with, so 2 to the x plus c. And that's it there. All right, power rule for real exponents. Let n be any real number and let u be differential function. All right, so let's say it's just kind of like an overview of our power rule. You know, bring down the power subtracted by 1. But we got to realize what we have for a power. All right. So e to the e down here. I'm down here. All right. E to the e. E is just a number. All right. That's all. E is just a number. So really, this is just a constant. It's a number to a number. This is a constant. The derivative of a constant is always 0. So e to the e power, the derivative of that is just 0. That's just a constant. We know already that the derivative of e to the x is going to be e to the x. We've gone over that already. All right, now look at c here. All right, it says x to the e power. Well, e, like I said, is just a number, so it's just like taking the derivative of x squared. Remember, we bring down the power, subtract it by 1. All right, so we're going to bring down the power here, so it's going to be e to the x times e to the, or e times x to e to the e minus 1. Sorry, e to the x times e to the x to the power e minus 1. There we go. I finally got it right. All right. And what about d? Well, that's not really a number for d, so we got to do a little logarithmic differentiation. So we're going to take the natural log of both sides. All right, let's take the natural log of both sides. So the natural log of x to the x. All right, remember our properties of natural logs. We're going to bring this down to the front. So I'm going to the natural log of y equals x times the natural log of x. We can take the derivative of that fairly simple. All right. We know the derivative of this would just be the derivative of stuff over stuff, so 1 all over y, right? Equals, well, dy, so it'd be y prime over y. Yeah, it's y prime over y because I took the derivative of natural log of y with respect to x. So y prime over y, all right? And then we can take the derivative of the other side by using the product rule, all right? And the product rule means we're going to take the derivative of the first one times the second one, so we're going to have 1 times the natural log of x, that's the derivative of x, plus then the first one times the derivative of the second one, the derivative of natural log of x is 1 all over x, all right? Well, these guys cancel out, so I have y prime over y equals natural log of x plus 1, and we can move our y over, remember from doing this a couple sections ago, so we have y prime equals y times natural log of x plus 1, and we already know what y equals way over here. Y equals x to the x power, so y prime equals x to the x times natural log of x plus 1. So if we have an exponent of x, all right, we gotta do something different. So we gotta use a natural log differentiation. Okay? That's it for today. We'll see you in class.